So today we're going to take a look at tree diagrams. So let's take this first problem here. And we're going to see what we can do with this. So, all right, so here we go. The probability that Sam hits a bullseye is 0.8 in darks, so 80% in darks, and he takes 2 shots. Assume the probability for each shot is the same. What is the probability that he hits 2 bullseye? Well, that's pretty easy. 0.8 times 0.8. So that would be 0.64. The next one, he hits only 1 bullseye. Well, he could hit or miss, or he could miss and hit. So he could hit and miss, or he could miss and hit. So 0.16 and 0.16 is 0.32. And if he could hit at least 1 bullseye, so that would be he could hit, or hit miss, or miss hit. So he could hit, so that's 0.8 times 0.8, plus he could hit and miss, 0.8 times 0.2, or he could miss and hit, so 0.2 times 0.8. So we have 0.64 plus 0.16 plus 0.16, so that would be 0.96. So another way of looking at this is with a tree diagram. So if we were to make a tree diagram here, Sam takes his first shot and he could hit it or he could miss it. So this is the first shot. So a 0.8 that he hits, a 0.2 that he misses. Well, then his second shot, he could hit or miss, hit or miss. So 0.8, 0.2, 0.8, 0.2. So this top line right here would be the probability that he hits and then hits. And if we multiply that line together, hit and hit, 0.8 times 0.8 is 0.64. This next line would be that he hit and he misses. So following that line, we have 0.8 times 0.2, so we have 0.16. Then we could do the same down here. So he misses and hits. That would be 0.2 times 0.8 is 0.16. He misses and misses. 0.2 times 0.2 is 0.04. So when you take a look at this, if we want to know he hits 2 bullseye, that's a double hit, 0.64. He hits only 1 bullseye, so 1 bullseye would be 0.6 and 0.6 for the 0.32. And hits at least 1. Hit, 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 miss, and hit, miss, hit. So we're going to try taking a look at this next one here. We're going to see if a tree diagram can help us. So the second one. A bag contains 5 green and 6 red balls. If 2 balls are taken out successfully without replacement, at least 1 is green. So again, you could do this without. What is the probability of getting a green green, or a green red, or a red green? But we're going to take a look at see if a tree diagram helps us. So let's see. In our tree diagram, the first draw, you could either get a red or a green. So red would be 6 out of 11. Green would be 5 out of 11. So the second draw, you could get a red or a green again. But if you notice here, it says it was taken out without replacement. So all of these on the second draw, these are going to be fractions out of 10. And here we drew a red one on the first one, so there's only 5 red left. So that means there's still 5 green. But this one, if we drew a green, there's only 4 green left and 6 red. So if we calculate out these probabilities, the probability of a red, 6 times 5, so we'd have 30 out of 110. A red green would be 6 times 5, 30 out of 110. a green red, 6 times 5, so we have 30 out of 110. And then a green green would be 5 times 4, 20 out of 110. And let's see if that matches up. So we want at least one green. So that would be this one, and this one. So if we add those together, 30, 60, 70, 80 out of 110. Again, we could have done it this way as well, a green green. So that's getting our probability 5 out of 11, but that we draw a green, so there would be 4 out of 10 left. Plus, let's say we draw a green, 5 out of 11, times, there's 10 left, how many red? There'd be 6. Plus we draw red, 6 out of 11, times there's 10 left, and we draw green. So those are the exact same probabilities that we're getting right here. We had a green and green, 5 out of 10, 4 out of 10. We had a green red, 5 out of 11, 6 out of 10. And then we had a red green. So red green, 6 out of 11, 5 out of 10. So we end up with the same thing. So let's see this last one. Red is picked on the first pick, given that at least one green is chosen. So what is our given? That at least one green is chosen. So this is that conditional. So how many had at least one green? Well, we found that up here. So that is 80 out of 110. But then we need the probability of both, because conditional. So remember, this is the probability of both. So red and at least one green over our given at least one green. So red and at least one green. So if we add those together, red is picked on the first pick, given at least one green. Well, that's only going to be that one, because it has to be on the first pick and a green. So that's going to be 30 out of 110. So we end up with 30 out of 80. Or we could reduce that down to 3 out of 8. Okay, and the very last one that we're going to take a look at. See if we can make this bigger here. Okay, there we go. So Toby is a rising star at the tennis club. He has found that when he gets his first serve in, the probability that he wins the point is 0.75. When he uses his second serve, there's a 0.4 chance of him winning the point. He is successful at getting the first serve in 3 out of 5 occasions and his second serve in on 3 out of the 4. So let's take a look here. We have his first serve. So what is his chance that he gets his first serve? So 3 out of 5. So that would mean that 2 out of 5 times he misses. Okay. So we could say that's success, and he fails on the first serve. Well, what do we know? He has found that when he gets his first serve in, the probability that he wins is 0.75. So that he wins and loses would be 0.75 and 0.25. All right, so let's see. So down here, when he misses the first serve, he gets a second serve. And let's see, his second serve, he gets in 3 out of 4. So success, failure, so this would be 3 out of 4 and 1 out of 4. So when he gets his second serve in, there's a 0.45 chance of him winning. So wins, loses, 0.45, 0.55. So it's kind of a weird looking tree diagram here. Because if he second serve and loses, he's just done on his first serve. If he misses both, then he's done. So if we take a look at this here, let's see what these questions are asking for. Find the probability that the next time it is Tony's turn to serve, he wins the point. So if he wins his point, he could make his serve and win, or he could miss his serve, make it, and win. So if we multiply all these probabilities together, let's see, 3/5 times 0.75. Let's see here. 3 divided by 5 times 0.75. So that's a 0.45 chance. So this one is 0.45 that he wins on the first. That he wins on his second, 2/5 times 3/4 times 0.45. So let's see, 2/5 times 3/4 times 0.45. So that's a 0.135 chance. So that he wins, we would add those together, and so that would be 0.585. So this next one, given that Toby wins the point, what is the probability that he got his first serve? So this is that conditional here. So our conditional is that given that he wins the point, and on the top, it would be win and first serve. So if we take a look at that win and first serve, that was 0.45. Divided by, he wins the point, well, we found that up there, 0.585. So if we take that, 0.45, divided by 0.585, we have 0.769.